Hello, my dear student. How are you all? I hope you would be well and safe. Myself, S.K. Trivedi. Today, I am going to discuss on SNI reaction. SNI reaction means intramolecular nucleophilic substitution reaction, and this is called Darjan's method. Intramolecular nucleophilic substitution reaction means an atom which acts as a nucleophile will present in same molecule. That is why it is known as intramolecular nucleophilic substitution reaction. Actually, this method is to prepare alkyl halides from a reaction of alcohols and thionyl chloride. Right. So when a thionyl chloride react with the alcohols, you will get alkyl chloride, and alkyl chlorides in the pure form, because of byproducts are in gaseous state. Byproducts are in gaseous state which will escape out, right? So that is why this is a good method to prepare alkyl chlorides. Okay. So we will take an example to discuss this reaction, right? Like CS3 hydrogen, and this is deuterium, and this is an alcohol, right? Because of stereochemistry, if you want to understand the stereochemistry of this reaction, so we are taking an example as CS3 HD and OH. This carbon will be chiral carbon atom, so that is why this is a chiral compound, right? To understand the stereochemistry of this reaction, we will take this example, okay? Because this carbon is chiral and that compound will be chiral compound, right? Now SOCl2 when react with this type of compound, it will form a CH3H and deuterium and chlorine, and SO2 and HCl, right? Okay, this HCl is also in gaseous state, SO2 is also in gaseous state, but this chloride you will get in liquid states. Okay, so that is why you will get a pure alkyl halide, because sulfur dioxide and HCl will escape out, right? There is no problem. Okay, so we will discuss the mechanism of this reaction. What would be the mechanism of this reaction? Okay. Now, this alcohol like CH3H, and this is the deuterium and OH. Oxygen, you know very well, oxygen having two lone pair of electrons, and when sulfur present in the thionyl chloride react with this, because of its electron deficiency, what would be the driving force? Here, look at this. Sulfur is an electron deficient atom because it has d orbitals. That is why. And here oxygen, you know, electron rich. Oxygen which present in this alcohol will be electron rich atom. So this will be a driving force. Okay, this is electron deficient and this is electron rich. So this electron rich atom will donate the electron pair to the sulfur, right? Because sulfur is a electron deficient, right? Okay, what will happen when this oxygen will donate the electron pair to the sulfur? Then it will get a positive charge, and that sulfur will get a negative charge, which will be neutralized by these electrons, because these electrons will go to the oxygen atom. Okay, this is the negative charge will present on the oxygen atom, right? This bond, this pi bond will shift towards the oxygen, right? And now you will get this situation. Okay, you can say hydrogen which present on this oxygen atom will be eliminated because of the positive charge present at the oxygen atom. you know about it, oxygen atom is electronegative atom, so it will not carry a positive charge. It will not carry a positive charge, right? That would be a very unstable condition, right? So this bond will be cleaved, okay? And now here you can say these electrons, these electron pairs will come to this bond again, and then here you can say chlorine atoms are there. Chlorine atoms are there, and you know about it. Chlorine atoms are good leaving agent. Chlorine atoms are good leaving agent. So when these electrons are coming towards the sulfur, then one atom have to leave. So that would be a chlorine atom, which will leave from this compound. Okay. So overall, you are looking here. Hydrogen is eliminated as a H positive, okay, and Cl is eliminated as a Cl chlorine negative. So they will combine with each other and form HCl. Okay, so we can say HCl molecule is eliminated from this compound, and after that you will get the situation as, okay, this is the oxygen atom and sulfur, and this is the fluorine, right? In this situation, you can say again sulfur is still electron deficient. So what would be the condition? Condition is that oxygen having still two lone pair of electrons. These two lone pair of electrons are attracted by the sulfur atom, right? Because of electron deficiency. Sulfur is still electron deficient, right? So what will happen? Now, when these electrons are shifting towards the sulfur, then a partial positive charge will present at this oxygen atom, and a partial negative charge will present at this sulfur atom. So what will happen ultimately, and this is also a RDS, rate determining step, because this is a crucial step, right? In this step, this bond will shift towards the sulfur atom due to the, and now you can say chlorine has three lone pair of electrons. When this bond will shift towards the sulfur atom because of electron deficiency, and to overcome the electron deficiency of sulfur atom, now this carbon having tendency to gain a positive charge, right? In this situation, this chlorine atom will donate their electron pair to the carbon atom, right? To the carbon atom. So that is why this is the RDS, rate determining step, and now the situation is that you will get CS3, H and D, and this will be a chlorine will donate, okay, and now when chlorine will donate, chlorine will also cleave this bond, right? Chlorine and sulfur bond will cleave in this situation, and chlorine ultimately is attached with this carbon atom, and this will be a bond formation between oxygen and sulfur, and this is the oxygen. So this is the sulfur dioxide, and this is the alkyl chloride, right? So you will get a retained product. In this mechanism, you can see chlorine atom is attached to same side, towards the same side where the OH that will leaving group is eliminated, right? OH group is eliminated. So that is why in this reaction you will get 100% retained product. 100% retained product. In the stereochemistry, that means if that chlorine atom will come towards the back side of this carbon atom, you will get an inverted product, right? The configuration will be inverted. But in this condition, you will get a retained product because the chlorine atom, which is attached with the carbon atom, will attack on the same side where this oxygen atom is going out, right? So this is the SNI reaction. This is very important reaction, and if we want to make a retained product, 100% retained product, retained alkyl chloride, then we will use this reaction. Okay, thanks. Thank you very much.